Hello everyone, welcome back to my channel. So here I am again in front of you bringing a very important and interview focused topic on memory. I'm going to cover different concepts like logical memory, physical memory, hard disk, register and process control block. But no, wait, I'm not going to cover the concept like what is physical memory, what is logical memory, because the internet is flooded with those concepts. Do the physical memory exist? Where do logical memory exist? What is the use case of process control block? Why is the registers needed? So these are the questions which are generally asked in the interview, and candidates are most likely to fail to answer these questions. So I have made a very simplified video on this topic and presented it in a pictorial form. So hope that it helps you guys. And if you like the video, then please do like and subscribe to my channel, because I will be bringing more such video, more educational video, and sharing my knowledge with you all. So happy watching. So after this video, you are going to wonder how easy it is to understand the concept of logical memory, physical memory, process control block and register. How variables are allocated memory in OS? Let's see. So here is a sample program on Calculator.cpp. As you can see here, two variables n1 and n2 are declared and have some values, and total is storing the sum of n1 and n2. We all know that the output of this program will be total equals to 5. But if you are wondering, or you are excited to see how internally the OS does all the calculation to make this output to us, let's see in terms of operating system and memory. So this Calculator.cpp is the program. When this program is executed, it's generate calculated.exe. Now all the exe which are generated is actually nothing but a process. Now process are allocated memory in the hard disk. So always take care of this, that whenever a program generates an executable file, it is a process. So all the exes are nothing but a process, and process are allocated memory in the hard disk. So this is the second picture. Here you can see that P1, P2, P3 are different processes, and they are allocated memory in the hard disk. Now these memory which are allocated to P1, P2, P3 are some block of memory inside the hard disk. This memory is nothing but the logical memory. So is it making a clear picture to you that where does logical memory exist? Now there is a concept of process control block. So what is that? Actually, each process constitutes a process control block where the memory block is divided into different segments like stack segment, data segment, heap segment and code segment. Okay, so as we have seen that in our program there are three variables declared, n1, n2 and the sum. So those variables are declared as the temporary variables. So all the temporary variables like n1, n2 and sum get memory allocated in the stack. So now here is the complete pictorial representation of memory. So you can see that hard disk has different processes, and here is the process control block. And when this process is executed, whenever any process executes, it is actually allocated a memory inside the RAM, and that memory which is inside the RAM is the physical memory. So where is the physical memory allocated? It is allocated in the RAM. So always remember that the logical memory is allocated inside the hard disk, and the physical memory is allocated inside the RAM. Now our CPU does not understand n1, n2 and sum. It understands only registers. So it performs all the operation using register. That is why RAM allocates all the process a set of register. Like here n1 is assigned to register R1 and n2 is assigned to register R2, and then in the CPU their sum is calculated using the operation register operation R1 equals to R1 plus R2, and the final sum is stored in sum equals to R1. Means sum is assigned the value of the register R1, and after that how this operation works, let's see. So move R1 comma N1, this will move the value of N1 to register R1. Move R2 comma N2 will move N2 to register R2. Add R1 comma R2 will perform the addition of R1 and R2 and store the result in R1. Now move @R1 comma sum. So R1 has the final addition result of R1 and R2, and when this move operation is performed, the value at R1 is moved to the sum variable that was declared. So this way, after the print statement, we get the output as sum equals to 5 plus 6 equals to 11. Okay, so I hope this concept is clear to you. So that's all for this video. One thing I want to clarify is operating system internal design is not very simple. It is actually very complex, and its conceptual representation vary from OS to OS. So whatever I have showed till now in this video is just the simplified version of the conceptual representation of how memory works. So if you find any doubt, please reach out to me, or you can comment on this video. And if you like it and find it helpful, then please do like the video, subscribe to my channel, because it motivates me to come up with more educative materials and share my knowledge with you guys. So hope you have a good day. Thank you so much.